Hunting for Water in the Inner Solar System, Part 1, Mercury and Venus. From Earth in May 2016, with safe solar lenses, we could see tiny Mercury in silhouette transit the Sun. This lineup of Sun, Mercury, and Earth happens about 13 times per century. Closest planet to the Sun, the intense solar wind constantly blows across the planet Mercury. Mercury has very slow rotation, extremely long days and nights. The side facing the Sun is very hot, averaging 800 degrees Fahrenheit, and the side facing away is very cold, minus 280 degrees Fahrenheit. Mercury is an old surface. Craters and craters make this familiar face of a famous mouse. The overlapping craters tell us that Mercury's surface is not changing very much with time, not weathering from wind or water. These are long series of old to new craters, from ancient to modern times, one on top of another. Look at the horizon of Earth compared to Mercury. Notice the almost hard edge of the horizon of Mercury. Earth has a soft edge, indicating an obvious atmosphere and clouds. Mercury has no haze from gases, only a wisp of extremely light atmosphere. Water should boil away without an atmosphere to hold it. But in the dark polar craters, there is water ice. The yellow colors have been added to show where there is strong evidence of water ice and other frozen volatiles. Why is it possible so close to the Sun? Mercury has 0.1 degree of tilt, almost none. The poles receive minimal light from the Sun. Deep inside polar craters, there is never any light. Mercury's north polar region, colored to show surface temperature, shows why this ice exists. Red-colored surface shows sunlit area, where the surface temperature is more than 250 degrees Fahrenheit. Purple shows the surface at the base of deep craters in permanent shadow. Temperatures here are less than minus 370 degrees Fahrenheit, 620 degrees cooler. The ice evidence is confirmed by the space probe Messenger and the Earth-based observations. There is strong evidence of water ice in deep craters on the poles of Mercury. Because of its very reflective, heavy cloud layers and closeness to us, Venus is bright in our sky. Venus orbits the Sun in the same direction as the other planets, but it rotates, motion of day, in the opposite direction, very slowly. Because of this slow rotation in the opposite direction of orbit, days and nights are very long. This prolonged day raises the temperature of this already hot planet. The first time ever we see the surface of Venus, it is March 1st, 1982. The Russian probe Venera 13 has landed, and we see familiar sights, dirt and rock. And then 2 hours later, the camera and spacecraft are crushed by the great air pressure of Venus, 90 times more than Earth's. The temperature is almost 900 degrees Fahrenheit. It is incredibly dry. Water on Venus? Not now. This painting suggests what the surface might look like now. Spacecraft don't last long on Venus. We study Venus from orbit using radar. Venus has been examined in depth with radar from space. The planet has evidence of continents and a seafloor without water. Here is Earth presented in the same style, but Earth has water in abundance. Where did the water go? Venus formed in the same part of our solar system as Earth, of similar materials and similar size. But Venus is closer to the Sun and receives twice as much UV radiation. Because Venus receives so much more solar energy, early oceans evaporated at a fast pace. Ultraviolet radiation from the Sun broke apart water molecules. Light hydrogen escaped into space, and heavier carbon atoms combined with oxygen to make carbon dioxide. The CO2 created a runaway greenhouse effect that brought this planet to its present condition. No water, crushing atmosphere, extraordinary heat. Beautiful and mysterious in appearance, the hottest planet holds another secret. High in the atmosphere, where the clouds are, the temperature is more like Earth's surface. If Venus had a faster rotation, and so a shorter day, then Venus would be a cooler planet, more like Earth. If Earth had more dry land in the tropics, then less water would evaporate, and Earth would be a drier, hotter place overall, more like Venus. Looking at the two planets closest to our Sun, we see water ice in dark craters of Mercury and evidence of ancient seas on Venus.